on the subscribe button and press on the bell icon to watch my all new videos.
So this is the video tutorial you required basically if you are preparing for GATE and you wanted to, I cannot guarantee, but yes, I can tell you the formulas I am going to share with you. Formulas I am going to share with you for MV, mechanical vibration. Alright, so this is a short video. In this short video I am going to share with you all formulas, almost all formulas, those already has been used to solve GATE previous year papers. Based on my experience, and I have solved more than 20 to 30 problems in mechanical vibration, only GATE problems I am talking about, and the most common used formulas I am going to share with you right now in this video tutorial. What are you feeling? What are you thinking? Cool? Okay, so let's go for it. First of all, you need to know stiffness, that is denoted by K. Many books follows different donation and different way to denote this K, but I am sharing with you that K is stiffness. Okay, so if stiffness is in series, okay, then this series, suppose that this is K1, this is K2, how to convert this series into 1? Why I am doing this? Because suppose that they ask you to find out omega. So we know that omega is equal to root under K by M. So we have to find out total stiffness of the system. So we have to find out distributed stiffness into single stiffness to find out this frequency. Okay, so if these stiffness are in series, to find out, suppose that this is K equivalent. To find out K equivalent, what we have to do? We have to do just like this, 1 by K2. Well, you have already done this in case of resistance. Okay, in case of resistance you have already done this in class 12th class, I think so. So after calculation, what we got, K equivalent is equal to K1 K2 K1 plus K2. So we can say this K equivalent is equal to K1 K2 by K1 plus K2. So this is the case for series, stiffness in series. But if you are talking about if stiffness are in parallel, suppose that this is in parallel, okay, K1 and K2, then what would be its K equivalent and total K? So total K is equal to, in this case, just add the stiffness K1 plus K2. Okay, now another most important example, and based on that example in GATE they have asked question, so definitely you should know. Okay, don't worry, I am sharing with you. Suppose that there is a mass and stiffness is given on the both side of the mass, so K1 and K2. Can you guess, is this given in parallel or series? Can you guess about it? This is in parallel. This is in parallel. Consider this case is in parallel and solve it. I am repeating again, consider this case in parallel and then solve it. Okay, so these are formulas first, and second, let's go for the natural frequency, that is Fn. Fn is equal to 1 by 2 pi into multiple omega n. So we can say this 1 by 2 pi root under K by M. What is K? Stiffness. M is mass. The unit of stiffness is Newton per meter and unit of mass is in kg if we are talking about SI unit. Now let's go for the next thing that is also important. What is that? Damping factor. This damping factor is denoted by zeta, and zeta is known as actual damping coefficient division critical damping coefficient. Okay, So it is C by CC, and C is okay. CC is known as 2. I mean CC is equal to root 2 root under Km. This is a damping factor. Okay. Now let's move to the next, logarithmic decrement. This is denoted by delta. Delta is equal to 2 pi zeta by 1 minus zeta square. Now here I will share with you something. Probably in the question you have to make relation zeta, this zeta and this zeta here, and based on this relation I have shared with you already tutorials, and of course they have as question in GATE. So if you are preparing for GATE, then relation in between formulas you need to understand. Once you will understand relation between formulas, then things become quite easier for you to solve numerical problems. Okay. And one more thing, we know that angular velocity is equal to 2 pi n divided by 60, and this relation is most important for solving numerical problems related to wheeling of shaft. And in case of wheeling of shaft, we know that omega equal to g by delta. This delta is known as deflection. This delta is known as deflection of the shaft. Okay, so these formulas are related to it. Now let's move to the other formulas. Yeah, of course I have to share with you all formulas. Those are most important. I mean, 2 more formulas are remaining right now. Okay, one is magnification factor, because there is relation between these 2 formulas. Magnification factor, factor. This is equal to 1 by root under 1 minus omega n whole square, it's again square, plus 2 zeta omega by omega n, its square. This is magnification factor. Now if we will go for transmissibility, then it's is equal to root under 1 plus 2 zeta omega by omega n a square, division is here, 1 minus omega by omega n square, its whole square, plus 2 zeta omega by omega n square. Now here is the key thing to understand. What's that? Let me share with you. Can you imagine relation between magnification factor and transmissibility? Yeah, let's see. We can write this equation as like this. Its transmissibility is equal to 1 plus 2 zeta omega by omega n square multiple magnification factor. Now if we'll say, if it is in resonance, then we can say omega is equal to omega n. Therefore what will happen? Omega by omega n is equal to 1. So we can put this value here, 1 plus 2 zeta whole square mf. So we can say also like this, 1 plus 4 zeta square into mf. This is transmissibility. So here is the relation between transmissibility, magnification factor and damping factor. That's why I have shared with you all these relation, and if you know all these formulas, then I hope 70% numerical problems you can easily solve. At least 70% numerical problems you can easily solve. Those has been asked in GATE previous year paper. Alright, so my motto is to share with you all formulas, most important formulas related to mechanical vibration in one video tutorial. So let me just review again about it. So in this video tutorial, what we have learned, all important formulas. We have started with stiffness, then we have gone for series and parallel, then natural frequency, then wheeling of shaft, and then damping factor, critical damping coefficient, magnification factor, as well as transmissibility. So all things we have learned in this video tutorial. I'll recommend you to write and try to remember and to understand and to remember for long time solved numerical problems. I preferably solve numerical problems from previous year paper. Thanks for watching. See you soon in my next video. Bye bye. Hello my dear, this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about damping factor and logarithmic decrement. And of course in this video tutorial only I will share with you a numerical problem which has been asked in GATE previous year paper. So definitely, so in this video tutorial you will learn about damping factor, logarithmic decrement, as well as a problem related to both the topics. Sounds cool? Now let's go for it. First of all, damping factor. Damping factor. What is damping factor basically? It is the ratio of actual damping coefficient divided by, on the divisions critical damping coefficient. And actual damping coefficient is denoted by C, critical damping coefficient is denoted by double C, and zeta, it is denoted by zeta, damping factor. Again we know that C by 2 root under Km, this K is known as stiffness and this M is known as mass. Well, these things are most important in case of damping factor. So in the GATE examination, what they do, basically they will relate these three things: zeta, C, 2 root under Km. If you can relate, they will give you this, find out this, and they will give and this value. So in this way you can find out related things, things related to it, right? So this is about damping factor. Now come to the logarithmic decrement. Just like in case of logarithmic decrement, it is denoted by delta. This is known as logarithmic decrement, right? So logarithmic decrement is equal to 2 pi zeta y root under 1 minus zeta square. This zeta is known as damping factor. So these two formulas, if somebody, when they have asked question in GATE, if somebody know this formula and that person practice a little bit about it, then definitely he or she could attempt the question quite easily with maintaining accuracy. Because I am sharing with you this formula because at least you have approach to solve the question before directly land on the question. So that is the reason I am sharing with you. Actually in my most of the videos I have shared first formula, then little bit basic concept about it, about the topic, then I have gone to the problem. So the same thing I am just following in this case also, in this video tutorial also. So are you ready to learn that question? I am sure you are ready, right? So let's go for it. So here is the question in front of you right now. You can read this question, I hope so. Well, I got pretty good camera as well as you can listen to me very with comfortable voice. That's why I got very good mic even. So don't worry about that. I will keep improving these things, okay, for your ease. Now in this question what we have given, a vibratory system consists of a mass of this. So most important thing is that you have to notice these things. A spring stiffness is 1000 Newton per meter. A dashpot with a damping coefficient is. So this is known as C, this is K, and this is M. We have given C, we have given K, we have given M. Okay. Now we'll go to the question first. What we have to find out basically. So in this question, first question, let's go for the first question. First question states that the value of critical damping of the system is. Suppose that there is a system, and in this system, what is the value of critical damping? We have to find out that. So we know that critical damping is equal to 2 root under km. So 2 root under km, right? So k is what? Stiffness 1000, m is 12.5. Well, before going to solve this equation, I have to check out units. Now let's check stiffness Newton per meter, kg. Both of them are in SI, so I don't have any problem to find out its unit, because the given unit of critical damping is also in SI unit, right? So we will not face any problem related to unit. So what we require right now, can you guess? Yeah, guess it. Calculator, absolutely right. So k 1012.5. Yeah, we got this one. We have to find out its root. We have got this one multiple 2. So the value we are getting is 223.606 Newton second per meter. So can you tell which one is the right answer? Yes, option A is the right answer for this question, right? Now let's move to the next question. In this question they have asked two straightforward question, right? Don't need to think too much, just you can find out the answer. So they told that find out delta, that is logarithmic decrement. We know delta is 2 pi zeta 1 minus zeta square, we know this. But what is zeta? Damping coefficient. But thing is that we don't know what is the value of zeta, don't have given in this question, but we do know zeta is equal to c by cc. So what is c? We have given c is 15, and we have calculated cc, that is 223.606, right? So do calculation again. 15 223.606. So we got here what is the value exactly we are getting here. It's a ratio, so there will not be any unit of this 8, right? So we are getting the value of zeta is here 0.06708, right? Now we have to put this value here. So 2 pi 0.06708. One more thing I would like to share with you, just to let me do little calculation, then I will share with you. Yeah, so 2 multiple pi multiple 0.06708, okay, divided 1 minus 0.06708 whole square 1 divided by 2. So answer I am getting here 0.422. okay, 0.422. okay, that's cool, no problem. So you can know exactly answer is not here, so A is the right option. Actually in GATE they did not give option here, so but by the way I have solved this problem. Yeah, I was talking, so I hope you understand this question, and the formulas I have shared with you earlier, and by using both the formula we can solve the problem quite easily. We don't need to face any problem in future, I must say that. Well, so the main thing I wanted to share with you, well, if you are studying vibration, mechanical vibration, then few topics are most important, but most important thing is one word I would like to recommend: practice. Yes, more you practice, you will get better approach. So in case of mechanical vibration, it's not an easy subject itself, okay? Probably you have studied this subject in your engineering, and I don't know in which semester you have studied, but yes, mechanical vibration is one of the tough subject. But thing is that you don't need to study all topics in for preparation of GATE. You have to prepare selected topics, just like, you know, free vibration, forced vibration, critical damping, and then logarithmic decrement, and then transmissibility, and I must say that critical speed of shaft or wheeling of shaft. These are most important topics. So what I have gone through, previous papers, I have seen most of the time in GATE examination they have asked question from these topics, right? So most of the thing is that what you require, basically you have to remember first formula, and then why I'm sharing with you, people do mistake here, and nowadays you are not going to get this calculator. So what is the problem basically you will face? You will have to calculate on your monitor only. You will get on screen calculator, you have to use that. So if you will not practice, that's why I have told you the single word. This is the key to get success in anywhere, not only in the competitive examination, in even life. If you practice a lot, you will become expert in that, and once you will become expert in that, I don't think so anyone can stop you to get success. So practice a lot and get success quite easily. So this word play most important role, remember that. Okay, I hope you understand this topic and the numerical problem I have shared with you. Thanks for watching. See you soon in my next video. Bye bye. My dear, this is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about mechanical vibration, of course, but there is a topic that is known as natural frequency. And in this video tutorial I am going to share with you a couple of questions. Those are really important, and this question has been asked in GATE previous year papers in different years. So if you wanted to solve this question, you need to know a concept and one single formula. If you know a single formula and a concept, then I am 100% sure you can easily solve the question. You don't need to you will not face any problem, right? So basically, how to solve these type of problems? Well, it seems really difficult to solve, because if you are beginner, if you haven't solved any question related to this topic, then you thought that solving this type of question is just like climbing a mountain, but it's not like that. It's really simple. So let's go for the basic foundation, then we will solve these questions. That's why you will not have any problem to understand, because directly if I will solve question, then probably you may face problem, right? So here is the foundation course, right? So basically, if you're talking about frequency, okay, then we have omega and f. So omega is known as angular frequency. So omega is root under k by m. What is k? K is stiffness and m is mass. Now how to identify k if it is not given, it is not written that this is stiffness, by through its unit Newton per meter and mass in kg, as you know this mass one. Okay, so I don't need to tell you. And if you're talking about formula for finding out natural frequency, then 1 by 2 pi root under k by m. Okay, so most of the time what happens, they ask for frequency, right? So you have to notice a little bit that when they're asking natural frequency, and what they wanted you to find out, right? So this is the formula. But how to find out stiffness when they are given in series and in parallel? Because the question I have shared with you, in these questions they have given combination of two series, parallel, series and parallel. So you need to know how to find out. Just like this one is in parallel, and if you say this one and this one is in series, if you find out from these two, then that output and the given this one will be in series. So how to find out parallel and series combination? It's really simple. Suppose that two things are given here, right? So if you'll say this is a stiffness, this is a stiffness, right? So K1 and K2 both are in series. So to find out K3, if you wanted to get one stiffness from these two, then what we have to do? K3 is equal to K1 plus K2, direct addition, right? If two stiffness are in series, this is the case for parallel. If we are talking about a series, case of series, then suppose that this is K1 and K2. Therefore, if we'll convert these two stiffness into one stiffness, suppose that K3, then we have to write 1 by K3 is equal to 1 by K1 plus 1 by K2. Then we have to find out what is K3 from here. Okay, can you find out K1, K2, K1 plus K2? So K3 reverse of this, K1, K2, K1 plus K2. So this is the value of K3. So in this way you can find out parallel and series combination of stiffness. These all things are really important to solve the coming those problems already come in the previous year paper. I don't know what type of question they will ask in the upcoming examination, but of course this concept is really important. Well, let me share with you how to solve those question, right? So we have a question. First of all, the first question is here, right? You can see. So in this question what we have asked, find out natural frequency of the given system. They have asked to find out natural frequency, right? So what we have to do, we have to first find out total stiffness from this diagram, from this combination, not diagram exactly, from this circuit, you can say stiffness circuit. So here this one and this one is in parallel, so we can say that k2 k by 2 plus k by 2 is how much? It's k by 2 and k by 2 is 2k, so is k. So you can say that you can draw this diagram like this, k and this one is also k and this is m, right? Now these two are in series, so how we can find out combined line? I mean, I wanted to find out only one stiffness, then only I can implement that formula which I have shared with you. So what is k equivalent? Totally k we have to find out. So whenever these two are in series, then we can write 1 by k e is equal to 1 by k plus 1 by k, therefore 2 by k, therefore k is equal to k by 2. Okay, this is a simple calculation, that's why little bit I am going fast. So we know that omega is equal to root under k by m, but here k is equal to what? K by 2, so k by 2m is the right answer. So k by 2m is the option D. Option D is the right answer for this question. So this is how you can solve question, I mean, without making any mistake. Okay, so this is the first question I have solved. Now we'll move to the next question. Okay, so in this question what exactly thing, there is a trick required. That means you need to know what type of combination is this. Now remember, whenever there is a mass in between two stiffness, that means both the stiffness are in not in series, are in parallel. That means this one and this one both are in parallel, because in between these two stiffness we have mass, that's why. So from this total stiffness, suppose that Ke is equal to K1 plus K2, because both the stiffness are in parallel. That's why 4000 plus 1600 is equal to 5600 Newton per meter. This is given in Newton per meter, right? So now what next? That is, they have as natural frequency. So we can say Fn is equal to 1 by 2 pi root under K by m. So 1 by 2 pi k is 5600 by m, m is 1.4. So let's find out. 5600 divided 1.4, 1 divided by 2 by 2 pi, 2 multiple pi, so it's 10.06 hertz. So which one is the right answer for this question? Option C is the right answer for this question. Now we'll move to the next question, that is given, just given, that's given here only, and this is also a simple question, but yes, you need to know how to solve this question. So in this question what we have been asked, a mass of 1 kg. Okay, first of all, m is equal to 1 kg, right, is attached to identical spring is stiffness k. K is equal to 20 kilonewton per meter. Don't forget to keep this thing kilo in your mind. That means 20 into 10 to the power of 3 Newton per meter. Remember that, right? Now both the stiffness are in series. If I wanted to get one stiffness, then K equivalent is equal to K plus K, therefore it's 2K, therefore 2 multiple 20 multiple 10 to the power 3 Newton per meter total stiffness, therefore 40 into 10 to the power 3 Newton per meter total stiffness, right? So this is it. Now what we have to find out, they have asked us to find out natural frequency of the system in hertz, natural frequency, right? So we know that natural frequency is equal to 1 by 2 pi root under k by m. So 1 by 2 pi, k is how much we have, 40 into 10 to the power 3, and m is 1 only, so don't need to do that. I mean, what's the use of that? 40 multiple 10 to the power 3, its root we have to find out. 200 divided 2 multiple pi is, it's 31.83 hertz. Now we have to match the answer, we have to find out the right answer. Well, I haven't right options, but yes, 31.83 is the right answer for this question. I hope you understand the basic concept as well as few question I have shared with you, and it's been only 10 minutes, and within 10 minutes you have learned how to find out natural frequency in different ways. And of course I have shared with you 3 questions, those already asked in GATE previous year paper. Well, thanks for watching. See you soon in my next video. Bye bye. This is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about 2 topics as well as GATE problems and an approach to solve numericals, right? So those topics are, first is damping factor and related about it, and next is basically in the question they have asked critical damping. Okay, they have asked to find out critical damping coefficient, and next is logarithmic decrement. So basically they have asked 2 questions. One is they have how to find out critical damping coefficient as well as logarithmic decrement. So basically why I am sharing with you first formulas, because I want you to have some, at least something about the numerical problems before going to read the question. Otherwise you will be like that blank mind. I mean, that's not possible to get attention or to understand the numerical problem directly, what I think. That's why I'm sharing with you first formulas. So what is basically damping factor? Okay, so damping factor, it is denoted by zeta, and its ratio is actual damping coefficient ratio critical damping coefficient. Actual damping coefficient is denoted by C, and critical damping coefficient is denoted by Cc. Further we can write this as Km, because critical damping is 2 root under Km. What is K? Stiffness. Its unit in SI Newton per meter, and M is mass, is its unit, can you guess, in kg in SI, right? So doesn't matter what question they are going to ask you. So these are the formula basically for damping factor, right? Now next topic is logarithmic decrement. It is denoted by delta, and delta is equal to 2 pi zeta by 1 minus zeta square. This is the formula for finding out logarithmic decrement. So can you understand this relation between damping factor and logarithmic decrement? So understanding the formula first is most important before going to solve numerical problems in any topic. Okay, well these days I am creating a lot of videos related to GATE problems. That's why you will have basic approach as well as concept to solve numerical problems. That is why all these videos are coming up. Okay, so let's go for that numerical problem which has been asked in GATE. And yes, if you are beginner, then I will definitely recommend you pause this video, write down these formulas before going to see the numerical problem. Okay, because these formulas play most important role. Well, I will share with you separate videos for mechanical vibration only for GATE point of view with most important formulas. Those formulas you must remember for solving numerical problems based on the previous GATE examination papers, right? So let's go for the numerical problem. So here is the numerical problem. Let me set, yeah, you can read the now numerical problem, right? So in this problem, what we have given, they said that a vibratory system consists of a mass. So mass is 12.5 kg. So you must write m is 12.5 kg. A spring of stiffness k is equal to 100,000, not 100, it's 1000 Newton per meter. Now what they said, a dashpot with damping coefficient of this. So they said damping coefficient, that means actual damping coefficient they have given 15 Newton second per meter, right? Now what we have to find out, critical damping. Okay, that means CC we have to find out. The formula I have shared with you to find out CC, that is 2 root under km. Okay, so K, what is K? I have shared with you, stiffness, that is 1000. And what is M? I have shared with you, that is, what is M? That is 12.5 kg. Okay, now what I required, can you guess, for doing further this numerical problem? Yeah, we required calculator. So 1000 multiple 12.5, so 1 divided 2 multiple 2 is equal to 223.606 critical damping Newton second per meter. Its unit also Newton second per meter. Okay, now can you guess which one is the, not guess, you have to see it, right? Because this is practical, there is nothing like prediction required. So check which one is the right answer. And here as you can see, the right answer is option A. Just mark that option and get marks. Okay, now next question is value of logarithmic decrement. We have to find out value of logarithmic decrement, that is delta. Delta is equal to what I have shared with you, 2 pi zeta by 1 minus zeta square. Okay, now what is zeta? Basically we don't know, so for solving further we have to get the value of zeta. So we know this, that damping factor zeta is C by Cc. C is how much we have given, 15, and Cc is 223.606, and it is unitless. So 15 divided 223.606 is equal to 0.06708. Okay, now what we required, we need to multiply this with 2 and then pi divided 1 minus 0.06708 whole square, right? So what we got from here, yeah, we have to find out its root 2. So root, so what we got value from here, that is 0.422. Yeah, and if you see option, we don't have option, so probably I have written wrong, or maybe the sample paper from here and the sample in the previous year paper they have chosen wrong answer. Okay, so the answer is 0.422. the right option is 0.422. so this is how you can solve question related to this damping factor, damping coefficient as well as critical damping. Okay, so I hope you understand this question. So let me talk 2-3 minutes, that's why you will understand the basic concept. So as you right now come to know that most important thing to solve the question numerical problems basically for gate is formula. First you required formula, first formula is required. Let me write first what required, you required formula. Okay, second what you required, approach. And third what you required, relation. What is the relation? Basically what is relation? Let me discuss. Relation between formulas. As you know here zeta and this one, formula for finding out zeta play most important role to find out the answer of logarithm, the value of logarithmic decrement. So all things required only one thing. If I'll say in one sentence what you required, that is practice. Practice what? Numerical problems you have to practice. Numericals. So solving numerical problems play really important role, remember that. And of course, if you can do this, then probably, if you can not probably, definitely there is maximum percentage of getting good marks in the examination. So this is about, this is about gate examination. And yes, if you are preparing for SSC JE and or even IES, you can get questions from these topics. I mean, these days I am making most important topic videos for most important topic based on the previous year paper. So I hope you are getting a lot of benefits from these videos. And of course, if you have any suggestion, then don't forget to share with me. I will definitely try to implement your suggestion in my upcoming videos. Thanks for watching. See you soon in my next video. Bye bye. Yeah, so this is Ujjwal Kumar Sen, and in this video tutorial we are going to learn about wheeling of shaft. Okay, so I hope you know, but this, what is wheeling of shaft and all that, probably you know, or maybe you don't know. I don't know about that. But yes, through this video tutorial you are going to learn about how to solve numerical problems for this topic in the GATE examination. Alright, so in this topic in this video tutorial I'm going to share with you exactly what is happening, what you require to solve numerical problems, right? So first of all, you required formula. Okay, so formula play most important role for solving numerical problems, especially numericals, not theoretical, right? Theoretical problems, okay, if you know about the basic of the concept, you can write. Suppose that we have a shaft here, okay, and the shaft, because of a shaft, I mean, if shaft is moving, and because of it is moving, and because of its vibration, there would be a little bit deflection, or maybe you can say because of vibration it will deflect from its axis. Suppose that it is deflecting from its axis, that is y distance. Okay, so we know that y is equal to E by omega n, natural frequency by frequency whole square minus 1. And the formula, I mean the question asked in GATE, which just I am going to share with you, in that question the use of this formula is nothing. So what formula they have used, that is omega n is equal to root under g by delta. In general, what we know, to find out natural frequency, that is omega is equal to root under k by m, to find out this omega. Or to find out natural frequency, we know that omega n is equal to fn is equal to km. We know that, we know this, right? So the formula we need to know to find out wheeling of shaft numerical, which has been asked in GATE previous year, that one formula, not this one, not even this one, not even this one. Alright, sounds cool. Now one another thing we need to know, angular velocity is omega is equal to 2 pi n divided by 60. This n is known as revolution per minute of the shaft of anything, for what you are finding out. Okay, so this is about the all important formulas of wheeling of shaft. Now let's go for that problem. Probably because of that you have been watching this video, right? So let's go for that problem. So here is the problem. So in this problem, this is a numerical problem which has been asked in GATE, and probably you can definitely read what is written in the question, right? So let me share with you what is written exactly in the question. So in this question it is written that a rotor shaft of a large electric motor supported between short bearings at both ends. Okay, so suppose that it is supported in both ends. Okay, both ends support. Okay, and its deflection shows 1.8 mm in middle of the motor, Assuming rotor to be perfectly balanced and supported at knife edges at both ends, okay, likely critical speed of the shaft. So what we have to find out, critical speed, and again in RPM of the shaft. So this shaft critical speed we have to find out. So data given in this question, that is delta is equal to 1.8 mm. The single data given in the question, and we have to find out n is equal to what is the value of n, we have to find out. Now let's review again those formulas, what formulas I have shared with you in this video tutorial. These are the formulas. So these are the formulas, related to wheeling of shaft. So can you guess which formula can help us to find out the answer? Only one formula here, and another formula is here. How? Let me share with you. Basically we know that omega is equal to g by delta, but omega equal to, again we know that 2 pi n divided 60. We'll put the value g, that is acceleration into gravity. We know that delta, and we have to find out n. That means we have everything perfect in this numerical problem. Just we need to go for it and solve it, then we will get answer. So why I said in the beginning of the video, formula is most important to solve numerical problems. Doesn't matter for which examination you are preparing. If you are preparing for numerical point of view, then we have to learn formula as well as relation between formulas we have to learn. That's why this relation I usually talk my video tutorial, because relation, without making relation in between formulas, you cannot solve. It's really difficult to solve gate problems, right? Problems related to gate. So let's go for it. Now what we got here, 2 pi n divided 60 is equal to 2 pi n divided 60 is equal to g by delta. So what, 9.81 divided by how much values, 1.88, right? And we will find out n is equal to what? Wrong approach. If you are thinking like this, you cannot solve this problem right away, because we have to see also unit. Without checking unit, don't solve even single numerical problem. Before going to solve the problem, check unit, because its acceleration due to gravity unit 9.81 meter per second square in SI. This is in mm. This is not given in SI. So we have to convert it into SI. So what we have to do, we have to multiply this this number, multiple 10 to the power minus 3 to convert into SI. So what we have to do, 9.81 1.8 multiple 10 to the power minus 3, right? Then only we can able to get right answer, is equal to what we have, 2 pi n divided 60, right? So what we require right now, calculator, right? 9.81 divided 1.8 multiple 10 to the power minus 3. Yeah, so we have to get its root this much. So this is how much we are getting, 73.8241 is equal to 2 pi n divided 60. We have to send this 60 to this side, and this one cross multiplication we are doing a simple, it's a simple problem, right? So 73.8241 multiple 60 divided by 2 pi is equal to n. So multiple 60 divided 2 multiple pi is equal to how much value exactly we are getting? 704.96 rpm is equal to n. Okay, now check the answer, which is the right answer among the option. Can you guess which one is the right answer among the option? That is C. C is the right answer for this question. Well, I have shared with you this single question only, and this question has been asked in GATE previous year paper. Hope you understand the question, right? Now let me tell you few other things about this. Okay, so if you are preparing for preparing for GATE examination, this is the thing you require. But if you are preparing for university examination, then theory is also important. You need to learn what is basically wheeling of shaft. Okay, that is also important. But here, what is delta? Basically it is deflection. That is also shared in the question. And it's deflection. What type of deflection? It is a static deflection, right? So how you can remember this thing for little long time? Solve problems. Just watching my videos can help you to understand basic concept, and you will come to know, oh yes, I can solve the problem. But whenever you will have only nothing, just have pen and paper to solve a question, you will have question, pen, paper, and of course a calculator, online calculator. That feeling is different than watching videos for solve videos. Okay, so this is about wheeling of shaft, and of course it is known as it is also sometimes called sometimes we have heard that wheeling of shaft is most important, right? So wheeling of shaft is really helpful for us. Study of wheeling shaft is also important in for any machine. Okay, so this is to avoid failure. So this is all about wheeling of shaft. Thanks for watching. See you soon in my next video. Bye bye. So this is Ujjwal Kumar Sen, and in this video tutorial you are going to learn about damping factor as well as damped natural frequency. Yes, so let's get started with this. What is damping factor? Well, if you are watching my videos, then definitely you come to know I have shared already what is damping factor. But one thing I haven't shared, that is damped natural frequency. So what is basically damping factor? This is denoted by zeta. Okay, and damping factor zeta is equal to, we know that, C by Cc. That means actual damping coefficient divided by critical damping coefficient. Okay, and here we also know Cc is equal to 2 root under km. K is stiffness, its unit is in Newton per meter, and m is mass, its unit is in kg. I have already shared with you, right? So this is all about damping factor. Things you required to solve numerical problems about damping factor, this is enough. But yes, if you are talking about natural damped frequency, then this is known as WD is equal to omega root under 1 minus zeta square. Damped natural frequency. Why I am sharing with you? I will share with you exactly where you are going to make mistake. Yeah, in this video tutorial you are also going to learn problems asked in GATE previous year. Alright, so that's why it will be helpful for you to for watching this video. Damping factor is good, but if you learn how to solve numerical problems related to this topic, damping factor, for if you are preparing for GATE, then you have to practice numerical problems which has been asked in GATE previous year, right? So let's go for that numerical problem. Are you ready, my dear? Are you ready or not? Tell me. I am ready to share with you. I hope you are ready. Okay, let's go for it. So we got the question here, and yes, I got very good camera for you. That's why you will not face any problem. Previously I got a little less costly camera. That's why many of my online viewers told me just focus that. That's why I got this camera. No issue, you will get best quality. Okay, I hope you are getting. So let's go for the problem. So in this problem, what we have said, that they have asked, A vehicle suspension system consists of a spring and a damper. Okay, no problem. A stiffness of the spring. So write down K is 3.6 kilonewton per meter. Here you will make mistake. I will share with you. Damping constant of damper, that is C, is equal to 4000 Newton second per meter. Okay, and if mass M is equal to 50 kg, then damping factor and damped natural frequency. Okay, then we have to find out zeta, that is known as damping factor, and Fn, that is known as damped natural frequency. Okay, so they have asked this one. Now what we required, we need to find out damping factor. Okay, first of all, go for damping factor. What is the formula for finding out damping factor? Zeta is equal to C by Cc. So C by 2 root under Km. So what is C here? 4000. 2 Km, K is 3.6, M is 50 kg. Okay, so we will do calculation. 4000 divided 2 multiple 3.6 multiple, okay, just a second, 3.6 multiple 50, 1 divided 2. Oh, this is the right answer. Okay, can you guess this right answer? No, this is a wrong approach. If you are solving like this, then you are making a mistake. Don't do this mistake. That's why I am just showing you live example where you can make mistake. Okay, so exactly mistake is here. It's 3.6 kilonewton. So what should we write? 4000 2 multiple 3.6 10 to the power 3 multiple 50. Then we can solve the question to get the right answer. So what we have to do now? 4000 divided 2 multiple 3.6 multiple 1000 multiple 50, its root and bracket close. So what exactly we are getting here? It's 4 point I think there is some calculation mistake, probably 3.6 4000. Okay, to 3.6. Let me check first. I will share with you. Of course, there it's 400, not 4000 exactly. Okay, that's why it was doing 400. Okay, so from where I have taken the question, I have just I have seen the previous year papers. It's 400, not 4000. So 400 divided 2 multiple 3.6 1000 multiple 50. So 1 divided 2 double close. So its answer is 0.4714. What is this? Damping factor. Now see the option. We have two options where we can match this, B and D. That means automatically C and D are wrong answer. Okay, it cannot be a right answer. Now what exactly you are going to do? You are going to just omega is equal to root under K by M, you are going to find out, or you will just tell Fn is equal to 1 by 2 pi root under 2 pi root under Km. You will put these values because already given and you will get answer. But that is the wrong approach. Why you will do this? You will just not notice this damped, because in the question they haven't asked you to find out natural frequency, they have asked you to find out damped natural frequency. So we have to notice this. Are you getting my point? So most important thing also is there, that you have to read the question carefully and understand each and every word what is given in the question. If you will not understand, then you will face problem, just like I have shared with you. You will do this and you get wrong answer, and definitely one of the answer will match with this. This is 1.35. okay, because I have seen this. I have done calculation, that's I'm sharing with you. So don't make mistake here. And now what you have to do, you have to use the WD is equal to omega multiple 1 minus zeta square. So omega is what we have to find out, that is root under K by M. So 3.6 multiple 1000 and m is 50 kg. How much value we are getting exactly? Let me find out. 3.6 multiple 1000 divided 50 is equal to 72. Its root is 8.4852 multiple 1 minus zeta square. Zeta is 0.4714. So multiple 1 minus point square, right? 1 minus 0.4714, its square, its root also. Okay, so what is the value we are getting? What's the value exactly getting? 7.48 radian per second. But again, this is a circular frequency. Again, what is they have as? We have to find out natural frequency. Therefore, what is it? Fn is equal to 1 by 2 pi omega d. So we have to divide this 7.48 divided by 2 pi. So what is the value we are getting exactly? 7.48 divided 2 multiple pi is equal to, okay, 7.48 divided 2 multiple pi, just a second, 2 multiple pi. So what is the value exactly we are getting? 1.19 hertz. Now match this value with, yeah. Now you can see you will make mistake here. You will make mistake here because you can mark this answer right answer, but this is not a right answer. Right answer is this one. I hope you understand the concept and approach to solve numerical problems, especially GATE. Okay, thanks for watching. See you soon in my next video. Bye bye.